Hello everyone, my name is Pibin Abram and in today's video we will talk about simple circuit. So let's get started. The first thing that we have to understand here is what is a simple circuit. So we all have studied simple circuit in our lower classes, right? So the simple circuit that we are going to discuss here is going to be simpler than the simple circuit that we have studied in our previous classes, right? So in our simple circuit we'll be having a bulb, we'll be having connecting wires, right, and we'll be having a cell or a battery, right? Okay, so in normal simple circuits there will be a switch also which is included. So for in this particular video we are not just including that switch. So in our circuit we'll be having a bulb, a battery or a cell and connecting wire. So what is going to happen here is the moment we connect everything according to this diagram, the current will flow from the positive terminal of the battery, right, and the current will be completed here, and because of the current this bulb will glow. Is that a yes or no? Right? Okay, now we can redraw this in this form also. So basically what I did here is, this is the same circuit, right, but the representation is different. Now here you have a bulb, right? So I can say my bulb is like a resistor, right? So it is giving some resistance in the flow of current, right? So instead of a bulb I'm actually making a resistor which is having a resistance of capital R, right? Okay, so in our previous video we got to know that your cell or your battery also have resistance, right, which we call as internal resistance, right? So and which is which is drawn outside the cell, right? This is the symbol of cell and we have internal resistance with it, right? Okay, so the bulb has a EMF E. Now what is your EMF? EMF stands for electromotive force. We have studied this in our previous video. For all those who haven't, who are not able to understand this, please go back, watch the previous video and then come back here, right? So what is your EMF? EMF is the potential difference across the terminal of the battery when there is no current taken from it, right? Or when this is not connected with a battery, right? Sorry, this is not connected, or this is not connected with a circuit, right? Okay, now this cell has a EMF E, has an internal resistance R, and obviously the current will flow like that. Is that a yes or no? I hope you guys can understand this. Yes. Okay, now in this particular video we will try to find out the value of current, that is the value of I in the circuit, and also we'll try to find out the value of internal resistance in terms of your external resistor, EMF and terminal voltage. Is that a yes or no? So basically in this particular video we'll try to find out the value of current, we'll try to find out the value of internal resistor, right? So how we are going to do that? Okay, let's try to do that. Okay, so basically, okay, so I have I have redrawn the simple circuit here, right? So what is going to happen? The current will flow. Yes, it will flow like that, right? Complete the circuit and the bulb will glow, right? So now in our previous video we came across this formula, V is equals to EMF minus I times of R. So for all those who are not able to understand this, please go back, watch the previous video and then come back here, right? Okay, now what is your V? V was the terminal voltage. V was your terminal voltage. Now what is your terminal voltage? Terminal voltage is the potential difference across the terminals of the cell when the current is drawn from it, right? Okay, great. Now that is equals to EMF minus your I times of R, right? Now I times of R is the loss in the energy or loss in the voltage because of the material that is present inside the battery or the cell, right? I hope that is understandable, right? So E was your EMF. EMF is the potential difference across the cell when there is no charge taken from it, and I times of R, where small r is your internal resistance, right? So this is something which we have to understand, right? Okay, great. So one thing is very sure, that this potential, that is a potential across your cell, will be known as your terminal voltage. Now the potential across your cell is given to me, that is V is equals to EMF minus I times of R, right? This is from our previous video, and this is from, and let me call this as equation number 1. So I'll just simply put terminal voltage V is equals to EMF minus I times of R, and this is my equation number 1. Is that a yes or no? Now there is one more thing which we studied, that is Ohm's law. Now Ohm's law states that whenever there is a resistor or there is a conductor, so obviously there is a bulb connected over here, right, which can be used or which can be visualized as a conductor or a resistance, right? So according to Ohm's law, the current that is flowing through this resistor is directly proportional to the potential difference across it, right? Now the potential difference across it is something which we already know, which is already given by this equation. But according to Ohm's law, potential difference is given as V is equals to I times of R. Yes or no? I hope you guys can understand that, right? So I can simply write in the next line is also the potential difference across the resistor or the bulb by Ohm's law is V is equals to IR. Now this is very important, right? You guys have to see equation number 1 and equation number 2 has the LHS same. So here also LHS is potential difference, and here also LHS is potential difference, and both the values we are talking about here is the potential difference across the same terminals. Is that yes or no? Obviously this and this and this and this, these 4 points are at, I should say these 2 points are at same potential and these 2 points are at same potential, right? So basically we are talking about the same potential difference here, right? So from these two equations, can I say my E minus IR is actually equal to IR? Yes or no? Can I write it like that? I hope you guys can understand that, right? Okay, so I'll simply write that down. By comparing both the equations, we will simply get E minus IR is equals to IR, right? And when you solve it, you can get the value of current to be is equals to EMF upon R plus R. Is that a yes or no? This is simply equals to EMF upon R plus R. I hope you guys can understand. So first part of our discussion is completed, that we got the value of current which is flowing inside our circuit. So now I know the value of current which is flowing inside my simple circuit, right? Now the next part that we have to derive or that we have to find out is the internal resistance. The value of R is something which we have to find out. Now it is also very simple. Now when I got the value of I is equals to E or EMF upon R plus R, all I have to do here in order to find out the value of small r is this I, right? We know from Ohm's law V is equals to IR, or I can simply say I is equals to V upon R, right? Substitute this value here. Instead of I, just write V upon R and solve it for the value of R, right? So that is what we are going to do here. Now in order to find the value of R, we substitute the value of I is equals to V upon R by Ohm's law in equation number 3. This is equation number 3. Substitute that value, and when we solve it, you will get your small r is equals to R, capital R, EMF upon V minus 1. Now two formulas today we are able to understand here. What are the two formulas? Number one, we got to know the value of current inside our simple circuit, that was coming out to be EMF upon external resistor plus the internal resistor, right? And we also got to know the value of internal resistance, that is given as R upon R bracket E upon V minus 1. This is something we are able to find out, right? So two values we are able to find out. So I hope that is understandable to everyone. So in order to make sure that you guys understand this, let's try to do a simple question or simple example from NCERT. So this is NCERT example number 3.5. Now before we proceed with this question, one simple information let me just share with you guys. So whenever we have a resistor, let's say this resistor has some resistance R1, I have another resistor connected in series to it, the equivalent resistance will be equal to simply R1 plus R2, right? Now this is something I'm sure you must have studied in our 10th standard, right? Also let's say you have two resistors which are connected in parallel to each other, right? Something like this. let's say this has some resistance R1, this has some resistance R2, then the equivalent resistance will be R equivalent will be equal to 1 upon R1 plus 1 upon R2, right? So this is how you calculate it, right? I hope that's understandable. Keep this in your mind before solving this question. This is note. So I'll just simply say this is note, right? Okay, now let's try to read the question here. Question says, a network of resistors is connected to a 16 volt battery with internal resistance of 1 ohm as shown in the figure 3.19. So you have the figure over here, right? So you have a resistor 4 ohm, then you have 1 ohm resistor, then you have 12 ohm, 6 ohm, and then it is connected with a battery of 16 volt, right? 16 volt is actually the EMF here. You have to understand 16 volt is actually the EMF of the battery here, and it is connected with a, and this 1 ohm is actually the internal resistor R of the battery. I hope you guys can understand that, right? Okay, compute the equivalent resistance of the network. So you have to find out the equivalent resistance of the network, first thing. Secondly, obtain the current in each resistor. You have to find out the current in each of this resistor. Okay, great, we'll try to do that. Obtain the voltage drop across VAB, VBC and VCD. So you have A here, B here, C here and D here. So we have to find out VAB, we have to find out VBC, and we have to find out VCD. So all the three things we have to find out. So let's try to do it one by one, right? Okay, let's talk about first thing, that is compute the equivalent resistance of the network. Now equivalent resistance we just discussed, right? So here you have 4 ohm and 4 ohm, they are in parallel, right? So let's try to find out the equivalent resistance of this circuit. So I'll just simply do it here. So I have 4 ohm and 4 ohm, right? So I can write it here. 1 upon R equivalent will be equal to 1 upon 4 plus 1 upon 4, and this will be equal to 4, 2, this 1 upon R equivalent, right? This 2, this is 2. So R equivalent is simply coming out to be 2 ohm, right? So the equivalent for this one is actually 2 ohm, right? And 1 ohm is already here. Let's try to find out the equivalent of this one. This will be R, 1 upon R equivalent, it will be equals to 1 upon 12 plus 1 upon 6. LCM will be 12. This is 1 plus 2, right? This will be 3 upon 12 is equals to 1 upon R equivalent, right? Or I can simply say 1 upon R equivalent will be equal to 4. So this is actually 1 upon 4, or R equivalent will be equal to 4 ohm. Yes or no? So I hope that is understandable. So we got 2 ohm and 4 ohm. So this is 4 ohm. Equivalent here is 4 ohm, right? Now you have 4 ohm here, 1 ohm here and 2 ohm here. There is 4, 1 and 2 ohm, and all of them are in series, right? So you will simply add all of the resistors, right? So 4 ohm plus 1, 5, 5 plus 2, 7 ohm. So the equivalent resistance, or I can simply say the A part, R equivalent of the entire resistance is actually 7 ohm, right? So I can now redraw this as, you have a 7 ohm, equivalent resistance, and it is connected with a cell with internal resistance of 1 ohm and 16 volt as the EMF here, right? Okay, now next part of the question is obtain the current in each resistor. So you have to find out the current in each resistor over here. So I have here 4 ohm, here I have 1 ohm, here I have 12 ohm and 6 ohm. I have to find out the current through each resistor, right? Now you have to understand, when the current come over here, the current, so let's say some I current came, and this I current is going to divide equally here. Why it will divide equally? Because here also it is 4 ohm, here also it is 4 ohm. So the current I will be divided into I by 2 and I by 2 here, right? And then again it will come back here I, and then again it will come back here I, but here the current will not divide equally, right? So let's try to do this. Let's try to find out the value of I first. So how you can find out the value of I first? So now let's look at this diagram here. We just got to know, obviously the current will flow like this. We just got to know the value of, or the formula of current, right? The formula of current is I is equals to EMF upon R plus small r, right? So I can find out the value of I from here. I is equals to, EMF is actually 16 volt. Okay, what is your equivalent resistance R? So this is your 7 plus internal resistance R is 1. So this is 16 upon 8, right? The value of current is coming out to be, yes, this is 8, 2 times of 16. This is 2 ampere. The value is coming out to be 2 ampere. The value of I is coming out to be 2 ampere. So one thing is very sure, that your 2 ampere current is flowing through your 1 ohm resistor, right? And also we got to know that your I current will be divided equally here, right? So obviously 2 ampere current is flowing. So from your 4 ohm resistor 1 ampere will go, and from your next 4 ohm resistor 1 ampere will go, and again 1 ampere and 1 ampere will combine here to become 2 ampere here, right? The only problem here is I do not know how the current is going to divide over at C part, right? Okay, now one thing is very sure, that the potential across your 6 ohm and across your 12 ohm will be same, right? Potential across your 6 ohm and 12 ohm will be same, right? So let me just draw it here. So you have 12 ohm here, right? And you have 6 ohm here, right? So the potential across here will be same. So from Ohm's law I can write potential across your 12 will be equal to potential across my 6 ohm resistor. So I can simply write V is equals to IR. Let's say some I1 current flows here, some I2 current flows here, and the value of I is actually 2 ampere. I is divided into I1 and I2, right? So this is something which you have to understand, right? So let's say I1 times of 12 is the resistance across this one, right, is actually equal to, yes, this is I2 times of 6, yes or no? All right, very good. So this will be equal to 6, 2. So your I1, 2 times of I1 is actually equals to I2. Now this is something I got one equation. This is something which I got here, right? So I can simply write 2I1 minus I2 is actually equal to 0. And also I already know one more equation here. What is the one more equation? That your I1 plus I2 is actually they will actually come out to be 2 ampere. Yes or no? So I can write it here. I1 plus I2 is actually equal to 2 ampere. All I have to do here is, add both the equations. So when I simply add it, right, you'll get 3 times of I1, right? This will cancel out, plus 0 is equals to 2 ampere, or I can simply say I1 is actually equals to 2 upon 3 ampere. So I got the value of I1, and very similarly put the value of I1 over here. You will get 2 by 3 plus I2 is equals to 2, or I2 is equals to 2 minus 2 upon 3. So this will be I2 will be equal to 6 minus 2 upon 3, and this will be 4 upon 3 ampere, right? So I got the value of I2 also. So what we have right now, so from your 4 ohm resistor 1 ampere current will flow, right? From your 4 ohm resistor again 1 ampere current will flow, right? From your 1 ohm resistor 2 ampere current will flow, right? And from your 12 ohm resistor, okay, let's see, 12 ohm resistor, 2 by 3 ampere current will flow here, 2 by 3 ampere current will flow, and here 4 by 3 ampere current will flow. I hope that is understandable, right? Okay, let's look at our third part of the question. Obtain the voltage drop across your VAB, VBC and VCD, right? Let me just erase everything so that we can understand it properly, right? So here I have the potential VAB across this one, and here the potential across is VBC, and here the potential across is VCD. Is that a yes or no, right? Okay, now here the equivalent resistance was which came out to be 2 ohm. Here the equivalent resistance is actually 1 ohm, and here the equivalent resistance was 4 ohm. Yes or no, right? And obviously I can assume that obviously 2 ampere current is going to go in all of these resistors. So basically I can redraw this figure as something like this. I can redraw this figure something like this. I have 3 resistor, right? This one is of 2 ohm, this one is of 1 ohm, and this one is of 4 ohm, right? And this is connected with a battery of 16 volt as EMF and 1 ohm as internal resistance, right? Okay, now very clearly I can simply say 2 ampere current is flowing here, right? And this is my A point, this is my B point, this is my C point, this is my D point, right? So when I talk about VAB, I can simply write, yes, I times of 2. I is actually 2 ampere. This is multiplied by 2 ohm. You will get 4 volt, right? Very similarly, VBC is simply equals to I times of 1. I is actually 2 ampere, 1 ohm multiplied. So this will be 2 volt. What about VCD? VCD will be equals to I times of 4 ohm. I is actually 2 ampere multiplied by 4. This is 8 volt, right? So when I add VAB plus VBC plus VCD, answer comes out to be 4 plus 2 plus 8, and answer comes out to be, yes, 14 volt, right? And which is actually correct, right? Because EMF of the battery is actually 16 volt. EMF is 16 volt. That means I can say 2 volt is actually lost in the form of heat. I hope you guys can understand this. Yes. Great. So if you have any doubt regarding this topic, you can ask me in the comment section. That's all for today. Thank you and have a nice day.